Kirk Math. All right, ladies and gentlemen, we are back. We are continuing with part 2 of 6.1, where we're going to look at examples 3 and 4. So if you are in your student companion, you should be on page 116 through 118. We're going to do a couple of problems as well, practice problems depending on time, but we have about a couple different examples to get through. So our first example 3, we're going to use the power of a power property to solve problems that look like this. Okay, we're kind of just taking what you learned with those exponent powers and taking them to the next step, where we're looking at these problems that have these powers that are equations or fractions, bases that don't match, and we're kind of putting everything together so you can solve any type of power problem. So the very first thing you're going to do when you have an equation like this is we are going to rewrite the bases, because if you notice, the thing that's different here than the problems we did even in our previous part is this base. Here we have a base of 27, and here we have a base of 3. And those are two different bases. We can only work with problems that have the same base. So if you're taking notes, you're going to want to make a little reminder that you need to have the same base number. Okay, have the same base number. So what that means is I'm going to have to go ahead and take a look at 27 and see if there is a way to rewrite it so that it has a base. Sorry, I'm trying to fix that. It doesn't like to work. That is also 3. So I'm going to quickly pop over here. And of course, you can't see my image very well because I'm zoomed in. Let me zoom out a bit. Fine. Here it is. Okay. So this is a chart of cubes and squares, and you need to try to memorize, honestly, to be helpful in both Algebra 1, Geometry, and Algebra 2. It is good for you to memorize your squares through probably around 12, 13. You should know when you look at a number, oh, 64, that's the square of 8. Okay, 144, that's the square of 12. And then you also need to know your cubes, okay? You should be able to look at 8 and know, oh, that's the cube of 2, right? 2 times 2 times 2 is 8. And one of those numbers is 27, okay? But you should probably know at least the first 10 of cubes for the most part. They get pretty big, so even if you know up to 5, that should be good enough. You might have to go through these again, but if you're memorizing cubes, I would go up to 12 on your squares and about 10 on your cubes. So anyways, if we look here, we can see that the cube root of 27 is 3. Or sorry, is 3. So what that means is that 3 times 3 times 3 is 27. So we can go back to our problem, and that's going to mean I can rewrite 27 as 3 cubed. Because again, 3 cubed is the same as 27. So because they are the same thing, I can replace one for the other. All right, so there we go. So once I replace 27 with 3 cubed, I can now start applying my power of a power property. Okay, any power raised to another power means I'm going to multiply. So now I have a distributive property problem. So think of it like distributive property. I'm really just distributing this power of 3, and multiplying it by x, and I'm distributing it to the minus 4. So that's how we get 3x minus 12. Okay, and I kind of drew that out here. After we have done our power of a power property, you now have your bases are the same. So that means I can cancel out the bases of 3, and I get the exponents equal to each other. So 3x minus 12 is the same as 2x minus 6. And now we have a normal problem that we can solve. Okay, I'm going to take away 3x from both sides. That's going to leave me with minus 12 on the left and minus x minus 6 on the right. Add 6 to both sides, and I'm left with a negative x is negative 6. Then I'm going to go ahead and change the sign. I want positive x. Multiply both sides by negative 1, and you'll get 6. Okay? This is just solving. From about here. Let me turn this one on. Here. From here down, this should be very familiar to you. This is the part that's new. Over here, this is new. Okay. All right, we're on to the next little part of this example. So we're going to look at a new problem. We still have the same initial problem of them not having the same base, but this base is also a fraction. So remember, if you come over here, when I have a fraction, I can turn that back into an exponent with a negative exponent, or into a power with a negative exponent, okay? So this, we need to remember this property here, okay? We also need to remember that when a base has a fractional exponent, that it is a square root, or it is a root or radical, and that the numerator goes inside the radical, and the denominator goes outside the radical. So we need those two properties, okay? So I wrote the problem a little bit bigger over here so you can see it, but let's take a look at their steps from the textbook here. So in order to solve this problem, it looks like there's got a lot going on. So we're gonna just simplify it piece by piece. So step 1, and if you're taking notes, this is a really good thing to do, write the equation so that both sides have the same base. That's gonna be your first step when solving problems like this, okay? Again, if I go back to, and I probably lost what page it was, if I go back to my squares and cubes chart, you should recognize 25 as the square of 5 and 125 as the cube of 5, okay? So now back at my problem, I'm going to, again, rewrite the equation so both sides have the same base. So I'm going to rewrite 125 as the cube of 5, and because it's a fraction, I'm going to make that exponent negative. I'm still keeping this exponent on the outside, so now we have a power of a power. On the right side, I'm going to rewrite the 25 as the square root of, or the square of 5. Because it's a fraction, I'm going to make it negative, and I'm going to keep this power. So if you are confused on how we went from 1 over 125 to 5 to the negative third, I kind of broke it down over here. So here's our original problem. Then I turned the denominator into a base of 5 to the third. Then I turned it into a negative to get rid of the fraction because of this property right here. Okay, so now we have this new part right here. Okay, so we did power of a power, and we multiplied the negative 3 times the negative x over 2 to get positive 3x over 2. And we multiplied, again, kind of like distributive property, the negative 2 times the negative x over 3 to get 2x over 3, and the negative 2 times the minus 2 to get plus 4. And again, if you're confused on how we get from this step to this step, over here, I kind of showed how we're multiplying power to power, distributing this power to the other power. Over here, this is how I multiply. This is how negative 3 times negative x over 2. I would multiply straight across, makes 3x over 2. Okay, so I kind of showed those steps so you can see why. All right, now we have something that has the same base. So we're going to do the same thing we did in the last one, and we're going to get rid of those equations. Step 2, write the exponents as an equation and solve. Eliminate those bases, and I have 3x over 2 equals 2x over 3 plus 4. Now I can solve. So we're going to eliminate our fraction by finding a least common denominator of our fractions, multiplying that, so that's 6. So I multiply this fraction by 6, and I multiply this entire 2 terms by 6. So 2x over 3 times 6 makes 4x, and 6 times 4 is 24. 3x over 2 times 6 is 9x. Now, again, this is the point where we have a normal equation, just one that you've seen before in last year in Honors Math 7-8, where we're going to solve from here down. Okay, this should be normal. Everything above this is new. If you still have questions about solving problems with variables on both sides, you can come and ask, or we can look for a YouTube video for that. But I actually have some on my Kirkwood math channel for 8th grade, and you're welcome to go and explore those videos. But you're going to end up with x.8 x equals 4.8. And then that's our solution. All right, so what you're going to do is try these two problems. Remember, the very first step we have to do is get our bases the same, okay? If you need to, you can pause right now and you can write down some important cubes and square roots to help you do that. Or you can find one online. All I did was look for a list of squares and cubes. And then you're going to solve this guy right here as well. I have my notes over here if you need to pause the video to use that to help you solve. All right, for this problem right here, we have a word problem. So Adam is setting up for an outdoor concert and he places 3 square blankets near the band as shown in this picture. And we want to know what's the area of blanket C. So they're going to use the information that is given to them. The area of the grass rectangle, this entire area, is equal to the length 8.5, the side length of blanket B. Oh, sorry, this grassy area here, 12, is equal to the side length of blanket B. And the width of blanket C, side length here. So this is this area here. Because we know the area of the grass and we know the length of blanket B, that will help us find the length of blanket C. Notice though that normally you would probably have used square roots to find, because the area of a square is x squared equals area. And so if I know the area is 8, then the side length would be the square root of area. Hold on. Would be the square root of the area. There. Woo. Anyways, and so because we know how to write that as a rational number, a fraction exponent, we're basically taking the area of the blanket and raising it to the power of 1/2. In order to find the length of blanket C. Then all we need to do is solve for this problem. So we have bases we're multiplying. You can see they multiply the numbers, and because the exponents are the same, they keep the exponent. Then they square both sides to get rid of that radical or that fraction, and now they can solve the problem. Okay, so that means that the area of blanket C is 18 yards. Go ahead and try that one on this page here. It's the same type of problem, so if you go back and pause here, you can follow these same steps. And then in this word problem here, we're focusing on the quotient of power properties. We're looking at 2 terrariums and their side lengths. The side length of A is twice B, and we want to know what X is. So they wrote this out here because they know that if they take terrarium A and they divide it by terrarium B, they'll get 2. So that's where this came from, okay? And then and the reason we are doing the cube root is because we're looking at volume, okay? And so for volume, you would be doing your sides, you'd be doing your sides cubed. And so the opposite of that will be the cube root. So they set their problem up, and then they're going to simplify. When I divide my powers, I subtract. So they're subtracting those exponents here, and then they're going to solve. And so again, because our bases are the same, we can eliminate them, and now we can solve our problem. And so the value of X is 4 in this problem here. Okay, you're going to go ahead and do the problem here. It's the same type of idea. Again, if you need some help, you can go back and pause and take a look at this. But it's the same stuff we've been doing. It's just with dividing instead of multiplying. We're just really focusing on making sure our bases stay the same.